Hello everyone. So I'm solving question number 1 from the internal 2 paper of data science. So let's get started with the video and I hope you like this one. So for question 1 we are talking about merging data sets. So imagine you work as a data analyst at a company where you got two type of Excel sheets from different branches of a company. So one branch measures the weight of their product in kilograms scale and the other one measures the product weight in pounds. So if you just go blindly and merge these two sheets, to find the average weight, your calculation is going to be completely wrong because the number aren't speaking the same language. So to fix this, we have to perform step called standardization, where this means we pick one standard unit, say kilogram, and we convert every single number into that unit before we do any math. This ensures that any apple in row 1 is directly comparable to the apple in the 100th row. So this brings us to the answer of this question. So when merging datasets with different measurements systems, ensuring consistency between unit is crucial. This consistency is what prevents those calculation errors and ensure our analysis is actually valid. So moving to the question 2, garbage in, garbage out. So question 2, so for the question 2, I'm gonna take you through an example of baking. So imagine you bake a cake. If you use rotten eggs and expired flour, it doesn't matter how amazing your oven is, but the cake will taste terrible. Data works the same way. If you feed a computer bad, messy data, no amount of smart coding can fix this result. We need a principle that reminds us to check the quality of our ingredient first. So this concept is known as garbage in, garbage out, and it stresses that analysis quality depends entirely on input data. So next one is artifacts. The question is on artifacts. I have just written my script like this. So the problem here is with question 3, that imagine you are scanning old photos, but your scanner has a piece of dust on the glass. Now every single time you click a picture, it has a weird black dot in the same spot. This dot isn't actually a part of the photo. It was created by the machine process. We need a name for this error that are introduced during the work, not before it. Here comes the thing of artifacts. So artifacts are systematic problems introduced during the data cleaning process that can be corrected. So yeah, always remember, do clean your lens while clicking pictures or shooting a video. Question number 4, that's about data loss, missing values. So with question 4, the question 4 addresses a worst case scenario. Imagine a sensor is recording temperature every second, but suddenly the power goes out for an hour. That hour of data isn't just messy, it simply doesn't exist. So the solution is that you can't clean what isn't there. We need a term to describe when information is physically destroyed or never captured in the first place. Irrecoverable information losses during acquisition, like a power outage, is a data loss or a missing value. Moving further comes mean imputations. So moving to question 5, you have a spreadsheet of employee ages, but a few cells are blank. If you just delete those rows, you lose variable information. A simple fix is to look at the average age for everyone else. Say they are around 30-year-old, and just plug the number into the empty short spot, so the math will work. Replacing missing data with the mean of existing values is called mean imputation. Just a simple thing, doesn't need to be explained with this whole bunch of letters, words. If a value is missing, just replace it with the mean value. Question number 6 takes that a step further. If you are tracking the temperature throughout the day, using the average might be wrong. But if it was 60 degrees at 9 a.m. and 80 degrees at 11, checking the average doesn't help. Instead, you look at the trend line where you can guess that at 10 a.m. it was likely right in the middle, around 70 degrees. You are connecting the dots. Filling missing values via linear regressions or curve fitting is known as interpolations. Now comes the turn for question number 7, that is raw data. So for question 7, imagine you spend hours editing a video, but you accidentally save over the original file. If you made a mistake, you can never go back to fix it. Data cleaning is destructive. Once you change a value, the old one is gone. That's why you must always keep a logged, safe copy of file exactly as they arrived. So always preserve both the raw data and the clean dataset. Question number 8, normalization. Question 9, sanity check. So for question 9, imagine your code finishes running and says that average age of your customer is around 5 years old. The code run without error, but the result is obviously impossible. You need a final review step where you look for extreme outliers just to make sure the data reflects reality. Outlier detection is often used as a sanity check here, so make sure to check your customer's age before doing any analysis. Now comes the question 10. So, have you ever opened a text file and seen a bunch of weird square boxes or question marks? This happens when the computer doesn't understand special characters. We use the special functions to stripe out these confusing symbols and turns them into a standard text that wouldn't cache the system. Functions like Unicode function help recover inconsistent characters during text or encoding repairs. So this is the ending of the section A. Let's get to the section B, that is about machine learning concepts.